Okay, guys, we're going to go ahead and go over 21, 23, and 31. So on number 21 and 23, actually, they're both very, very similar. So if you get, after I show you one, you might be able to do the other one. On 21, they give you the area of a rectangle. I don't remember what the context is, rug or whatever, but the area of this square is 100 r squared minus 220 r plus 121. And they want to know what are the dimensions of this, square. So in order to do that, we have to factor it. Now, first thing you do when you factor is factor out a GCF. Unfortunately, 100 and 121 do not have any common terms. So, or common factors is what I should say. No common factors. So, there's no GCF we can take out. Next, is there a special case that we can use? Well, this is a trinomial, so our only option in special cases is this a perfect square trinomial? If we look at the first and the last term, 100r squared, that's a perfect square because 10r times 10r equals 100r squared. 121 is a perfect square because 11 times 11 is a perfect square. So if this is a perfect square, this would factor to 10r minus 11 squared. It would factor to a binomial square. Notice that the sign between the two terms is negative because that middle term is negative, or minus because the middle term is a minus. Okay? Now, we know that the first term and the last term are going to work, but we still need to check the middle term. So in order to check the middle term, we would just multiply it out. So I would do 10r minus 11 times 10r minus 11, because that's really what this means. 10r minus 11 times 10r minus 11. All right, when we do that, 10r times 10r is 100r squared. 10r times negative 11 is a negative 110r. Same thing, 10r times negative 11 is negative 110r. And finally, negative 11 times negative 11 is 121. Okay, when we do that, the first term is 10r squared. That's good. Last term is 121. That's good. Now we need to see what the middle term would equal. Negative 110 plus a negative 110r equals negative 220r, which is exactly what we wanted. So that is good. So that means the side lengths of the square are 10r minus 1 and 10r minus 1. Or if you were just factoring it, you could write it like that too. Okay? All right. I would see if you can do number 23 on your own now if you had a question on both of them. But I'll do 23 as well, so you can check your answer with mine and go through your work. So for 23, the area of a square is 25r squared plus 30r plus 9. So same process. Is there a GCF? 25 and 9 don't have any like terms, so there's nothing there. But then is it a special case? Well, if it is, that would mean 25r squared and 9 are perfect squares. 25r squared, that's a perfect square because 5r times 5r equals 25r squared. And 9 is a perfect square because 3 times 3 equals a perfect square. So if this is a perfect square trinomial, it will factor to a binomial square. Since the middle term is positive, my binomial is going to be separated by addition. So it would be 5r plus 3. Now, we know that our first term and our last term will work, but we still need to check this middle term, okay? So we can do that by working backwards and multiplying it out. 5r plus 3, 5r plus 3, and then multiply. So 5r times 5r is 25r squared, just like we predicted. 5r times 3 is 15r. 5r times 3 is still 15r, and 3 times 3 is 9, again, just like we predicted. When we combine the 15r and the 15r, combine our like terms, we'll get 30r. That is perfect because that is our middle term. So that means that the dimensions of this square are 5r plus 3 by 5r plus 3. Okay? Hopefully you got that right the second time. All right, number 31 is slightly different. It actually has more to do with the next set of problems we're going to get into. Number 31 gives you the problem 81r squared minus 1, and they want you to factor it using a special case. The two special cases are a perfect square trinomial will give you a binomial square, or a difference of two squares will give you the product of a sum and a difference. Now, since this is a difference right here, and 81r squared is a perfect square, 9r times 9r will equal 9r squared. 1 is a perfect square because 1 times 1 equals 1. So now we have perfect squares, two perfect squares here, and they are separated by subtraction, so that's a difference of two squares. A difference of two squares factors to equal the product, means multiplication, of a sum and a difference. And we would be doing 9r plus 1 and 9r minus 1. To check our answer, if we felt like we needed to check it, we can just multiply those two together, 9r plus 1 and 9r minus 1. 9 times 9 is 81r squared, perfect. 9r times 1 is 9r. 9r times negative 1 is negative 9r. And finally, negative 1 times 1 is 1. 1 is what we wanted there, and then 9r plus 9r does equal 0, so those cancel out. So this works. So the factors are 9r plus 1 times 9r minus 1. Okay, in the next video, I'm going to do 37, 39, 41, and 43.